All right, we're going to read some science today. If you want to join me in reading Unit 1, Lesson 3, Surface Water and Groundwater, you can find this section in your book on page 30. And I would love to read it for you, and you can follow along. And if you want to read by yourself without hearing my voice, that's okay too. All righty. Some vocab terms on page 31 to be aware of are surface water, groundwater, water table, channel, tributary, watershed, divide, and aquifer. Page 32, getting your feet wet. Where on earth is fresh water found? About 97% of Earth's water is salty, which leaves only 3% as fresh water. Most of that small amount of fresh water is frozen as ice and snow, so only about 1% of Earth's water is fresh liquid water. This fresh liquid water is found both on and below Earth's surface. This tiny percentage of Earth's water must meet the large demand that all living things have for fresh, clean water. In addition to providing drinking water, fresh water is used for agriculture, industry, transportation, and recreation. It also provides a place to live for many plants and animals. On Earth's surface, water above Earth's surface is called surface water. Surface water is found in streams, rivers, and lakes. It either comes from precipitation such as rain or from water that comes up from the ground to Earth's surface. Springs are an example of underground water coming up to the surface. Surface water flows from higher ground to lower ground. Water that flows across Earth's surface is called runoff. Eventually, runoff can enter bodies of water. Not all runoff becomes surface water. Some runoff and surface water seep down into the ground. Water drains through the soil and filters down into underground rocks, collecting in spaces between rock particles. The water found in the spaces between rock particles below Earth's surface is called groundwater. Most drinking water in the United States comes from groundwater supplies. To use these supplies, people drill down to the water table to reach reservoirs of groundwater. The water table is the upper boundary or surface of groundwater. Turn to page 34. How does water move on Earth's surface? As precipitation falls on Earth's surface, it flows from higher to lower areas. The water that does not seep below the surface flows together and forms streams. The water erodes rocks and soil, eventually forming channels. A channel is the path that a stream follows. Over time, a channel gets wider and deeper as the stream continues to erode rock and soil. A tributary is a small stream that feeds into a river and eventually into a river system. A river system is a network of streams and rivers that drains an area of its runoff. Page 35, within watersheds. A watershed is the area of land that is drained by a river system. Streams, rivers, floodplains, lakes, ponds, wetlands, and groundwater all contribute water to a watershed. Watersheds are separated from one another by a ridge or an area of higher ground called a divide. Precipitation that falls on one side of a divide enters one watershed, while the precipitation that falls on the other side of a divide enters another watershed. The largest watershed in the United States is the Mississippi River. It has hundreds of tributaries. It extends from the Rocky Mountains in the west to the Appalachian Mountains in the east, and down the length of the United States from north to south. Many factors affect the flow of water in a watershed. For example, plants slow runoff and reduce erosion. The porosity and permeability of rocks and sediment determine how much water can seep down into the ground. The steepness of land affects how fast water flows. over a watershed. In rivers and streams, gradient is a measure of the change in elevation over a certain distance. In other words, gradient describes the steepness or slope of the land. The higher the gradient of a river or stream, the faster the water moves. The faster the water moves, the more energy it has to erode rock and soil. A river's flow is the amount of water that moves through the river channel in a given amount of time. Flow increases during a major storm or when warm weather rapidly melts snow. An increase in flow causes an increase in a river's speed. Materials carried by a stream are called stream load. Streams with a high flow carry a larger stream load. The size of the particles depends on water speed. Faster streams can carry larger particles. Streams eventually deposit their stream loads where the speed of the water decreases. This commonly happens as streams enter lakes and oceans. In deep water, how does groundwater flow? Although you can see some of Earth's fresh water in streams and lakes, you cannot see the large amount of water that flows underground as groundwater. Earth has much more fresh groundwater than fresh surface water. It trickles down from Earth's surface. Water from precipitation or streams may seep below the surface and become groundwater. Groundwater is either stored or it flows underground. It can enter back into streams and lakes, becoming surface water again. An aquifer is a body of rock or sediment that stores groundwater and allows it to flow. Recall that the water table is the upper surface of underground water. The water table can rise or fall depending on the amount of water in the aquifer. In wet regions, the water table can be at or just beneath the soil's surface. In wetland areas, the water table is above the soil's surface. It fills tiny spaces underground. An aquifer stores water in open spaces or pores between particles of rock or sediment. The storage space in an aquifer is measured by porosity, the percentage of the rock that is composed of pore space. The greater the pore space is, the higher the porosity is. A cup of gravel, for example, has higher porosity than a cup of sand does. Permeability is a measure of how easily water can flow through an aquifer. High permeability means that many pores in the aquifer are connected, so water can flow easily. Aquifers with both high porosity and high permeability are useful as a water source. Page 37, it is recharged and discharged. Surface water that trickles down into the ground can reach the water table and enter an aquifer. This process is called recharge and occurs in an area called the recharge zone. Where the water table meets the surface, water may pool to form a wetland or may flow out as a spring. The process by which groundwater becomes surface water is called discharge and happens in discharge zones. Discharge can feed rivers, streams, and lakes. Groundwater is also discharged where water is extracted from wells and are drilled down into the water table. Through discharge and recharge, the same water circulates between surface water and groundwater. Making a splash, page 38. How do people use surface and groundwater? About 75% of all the fresh water used in the United States comes from surface water. The other 25% comes from groundwater, but surface water and groundwater are connected. In human terms, they are one resource. People use this freshwater resource in many different ways. For drinking and use at home, groundwater is an important source of drinking water. Surface water is used for drinking too. Fresh water is also used in many other ways in homes. In a typical home, about 50% of all water used is for washing clothes, bathing, washing dishes, and flushing toilets. About 33% is used to water lawns and gardens. The rest is used for drinking, cooking, and washing hands. And lately, the hand washing usage of water has probably gone way up. For agriculture, activities like growing crops and raising livestock use about 40% of fresh water used in the United States. These activities account for about 70% of all groundwater use. A little over half the water used in agriculture comes from surface water. A little less than half comes from groundwater. For industry, almost half of the fresh water used in the United States is used for industry. Only about 20% of this water comes from groundwater. The rest is surface water. About 40% of water used in industry helps cool elements in power plants. For transportation and recreation, surface water is also used to transport products and people from place to place. In addition, people use rivers, streams, and lakes for swimming, sailing, kayaking, water skiing, and other types of recreation. Page 39, troubled waters. Each hour, about 15,114 babies are born around the world. The human population has skyrocketed over the last few hundred years, but the amount of fresh water on Earth has remained roughly the same. The limited supply of fresh water is an important resource that must be managed so that it can meet the demands of a growing population. Scientists are developing technologies for obtaining clean, fresh water to obtain global needs. Here in the picture, a boy uses a straw, a water purifier straw, that filters disease-causing microbes and certain other contaminants from the surface water. The straw is inexpensive and can filter 700 liters of water before it needs to be replaced. That's about how much water the average person drinks in 1 year. Like many places on Earth, Zimbabwe is experiencing severe water shortages. The country has been plagued by droughts since the 1980s. Scientists estimate that about 1 billion people around the world do not have an adequate supply of clean, fresh water. That ends the reading for Unit 1, Lesson 3. Thanks for listening.